Traditionally, it's very easy to introduce a guest speaker. You give the facts about his or her life, talk about their accomplishments, add maybe a joke or two, and then you're done. But this year, our speaker is someone many of us all know, former COA president, Dr. Stephen Katona. So instead of just reiterating much of what you've heard before, I thought I might share a different aspect about him. When I was given this opportunity to introduce Steve, I knew I wanted to somehow portray his personality the best that I could, to share how his endearing presence has impacted everyone who's been lucky enough to know him. I was talking to a friend the other day about how she first met Steve, which was at a sperm whale necropsy about 4 years ago. She hadn't met him before, and she had just been cutting up a huge dead whale. Coming onto the scene, Steve came right up to her, grabbed her hands, brought them to his face, took a huge whiff, and said, "Ah, I love the smell of dead whale." This is just the type of story that shows huge passion and total commitment for something that you love. If you've never had the pleasure of smelling a dead whale, it's probably one of the most putrid smells you could ever come across. This story is also a perfect explanation of Steve's personality, friendly, sincere, and often popping up randomly with unexpected charisma. I first met Steve as a prospective fly-in student to have dinner at his house. After getting to know him, I remember being taken aback by his down-to-earth and unassuming personality. I went to a really large high school with about 3,000 students, and I can't even really remember my high school principal's name. So the warm welcome that I got when I met Steve was one of the main reasons I decided to come to COA. One of the things that I found really fascinating about Steve is that he studied the very largest to the very smallest of animals. My very first year here, I took a marine science class in the winter. We had a surprise guest speaker one day for class, and in strolled Steve Katona. I was expecting a very scientific and professional talk, so I gave him my most focused attention. Instead, he shared with us a very energized zooplankton mating film he made in the 1970s, which was set in the background of upbeat, energetic 1970s rock music. I knew Steve had studied whales, but I had no idea about his exciting passion for zooplankton. Ever since then, I've always looked at plankton with a dramatic new light. Steve is also a famous whale biologist and the founder of Allied Whale, as many of you know, despite the fact that he was raised in Ohio, 1,000 miles away from any large body of saltwater. I'm also from the Midwest, and Steve's accomplishments have been a personal inspiration to me to pursue my focus of marine science while at COA. Our graduating class is the last class to have had Steve as our president before he retired after our freshman year. We're the final class to have a personal connection with Steve, to remember the stories, his leadership, and all the things he's done for the college. Hold that legacy with you, because it's also a lesson in human ecology. As we move on to life after COA, perhaps we could take one last lesson from Steve, as he is also moving forward. Since retirement, Steve has been working with the New England Aquarium in Boston, consulting on projects about climate change and its effect on the marine environment, heading a project that looks at how the ocean is responding to human activities, and also working on developing programs on renewable energy and green vehicles. Hardly a retirement, I'd say. Maybe he can give us some good tips on how to burst out of the COA bubble today. So it gives me very great honor and pleasure to introduce Steve to my friends and family today. Everyone, especially class of 2009, please give a very warm welcome for Dr. Stephen Katona.
Thank you, David. And thank you, everyone. Laura, that was just a very heartwarming introduction. And I should probably stop now because I'll screw up your opinion of me. Well, I want to thank you. I'm thrilled to be here today and to see the college thriving and to help celebrate the class of 2009. And I especially thank the class for inviting me to speak. I think you know how deeply Susie and I appreciate that invitation. I'm also conscious of the fact that I'm the last obstacle between you and these diplomas. My speech won't be as long as you fear, but it probably won't be as short as you wish. And my immediate goal is that I stop talking and you stop listening at approximately the same time. I've got a wonderful story to tell, and I hope I can do it as well as you graduates who presented your stories yesterday did. 5 months after I retired from College of the Atlantic in 2006, I was diagnosed with leukemia. A genetic mutation in one of my immune system's B cells had ruined its control system, allowing it to reproduce endlessly and to populate my immune system with white blood cells that didn't do their jobs as well as normal cells, and also were more liable to future mutations. What was I to think of these maverick cells? I didn't hate them. How could I? They were genetically the same as the rest of me, except for one mutation. But they weren't lovable either, since their selfishness threatened an early end to my days, so they had to go. And chemotherapy here at the Mount Desert Island Hospital during the first half of 1907 appeared to accomplish that. But nevertheless, my physicians down at Dana-Farber Cancer Institute in Boston thought that any cells missed by that chemotherapy would cause further trouble in several years, and they suggested that the only real chance for a cure was a stem cell transplant, which itself is a procedure not without risk. So Susie and I elected to roll those dice, and the search for a donor began. Now, the odds of finding a perfect donor, that is someone whose 7 genes of the histocompatibility system match mine perfectly, are about 1 in 100,000. That's about 200 times worse than the odds of the worst horse in today's Belmont Stakes winning. On the other hand, it's about 200 times better than your chance of winning the main lottery. So, of the 6 million people listed in the National Registry of Bone Marrow and Stem Cell Donors, 22 were perfect matches for me. But 21 couldn't be found, or for one reason or another, couldn't donate. The remaining person, a 59-year-old woman, agreed to donate. Now, transplants are highly choreographed procedures. On my end, following 4 days of chemotherapy to kill the stem cells that made my blood and immune system, at 7 o'clock on January the 30th, 2008, a courier brought to my room at Brigham and Women's Hospital a plastic bag filled with what looked like raspberry sorbet. And by the end of that hour, the cheerfully colored stem cells contributed by my donor had flowed by catheter into me, and my life as a chimera had begun. I can't begin to thank all the amazing people who helped Susie and me through the subsequent months of masks and gloves and germ avoidance and avoiding dirt and sun and plants and animals in public places like this. But all has worked out happily. I feel great. I'm probably cured, though I'll be on medications for a long time to suppress my new immune system from attacking the rest of me as a foreign body. Only after a year passes does the hospital facilitate communication between the donor and the donee, and only if both of them wish to make contact. We did. So a couple of months ago, my donor told me that she gave a blood sample 15 years ago during a donor drive for a member of her synagogue who was ill, but she wasn't a match. And 14 years later, the registry called her on my behalf. And it was a good thing, too, because she was approaching the 60-year age cutoff for donors. During the 4 days while my stem cells were getting killed, she received daily shots to stimulate production of her stem cells. And then she gave blood at the hospital, and her stem cells were taken out, the blood returned to her. She reported no pain except for a mild rib ache from the stimulation of the shots, stimulating her bone marrow. And on May 13th, Susie and I traveled to New York to meet her and to attend services at her synagogue, where the rabbi introduced me to the congregation and acknowledged my donor's contribution to keeping me alive, and quoted from the Torah that when you save a life, you save a universe. President Obama quoted from the Quran during his speech in Cairo on Wednesday, and it says that whoever saves a person, it is as if he has saved all mankind. Well, I don't think I'm worth the accounting given in either scripture, but I'm glad to be saved anyway. Thank you. Well, thank you. Capping it all off was the revelation that my donor's name is Susan, like Susan, with whom I've spent the last 45 years or more. Rose is her middle name, that's my mother's name, and her last name is Newman. And I thank her for making me a new man and enabling me to be here today and for helping to inspire this talk. 4 years ago, at your convocation on September the 7th, 2005, I welcomed this class with a talk about the rhythms of our lives. And one of you, at least, has acknowledged even remembering that. And I finished with the thought that our human lives are part of a giant chorus sung by countless singers, a huge, pulsing, polyrhythmic symphony that connects everything: the electromagnetic vibrations of atoms and photons, the precession of Earth's axis, the slosh of tides, and the pounding of storm waves, the swoosh of charged particles down Earth's magnetic lines of force, the dance of the northern lights, the ponderous movements of crustal plates, the advance and retreats of glaciers, and the more delicate rhythms of life, the calls of frogs and crickets, the flashing of fireflies, the spawning of corals, the transoceanic calls of blue whales, and the awful and wonderful noise of our own culture. And with the hope that by coming to know ourselves and some of our fellow choristers better, we could improve the quality of our lines in this Earth song. And today I'll try and complete that talk, first highlighting a major obstacle frustrating that hope, and then suggesting a better way to get where we need to go. The obstacle is our enchantment with opposites. Maybe it's our bilateral symmetry that's to blame, defining left and right and front and back, but leaving us mainly adjectives to describe things in between. Whatever the reason, we like to polarize things, like mass and energy, wave and particle, human and non-human, mind and body, self and non-self, each and other, good and bad, male and female, black and white, strong and weak, and so on. In fact, few things are entirely one or the other, and some of both is a pretty good place to be. I want to focus on the each-other continuum, as the words each and other contain a tension that both nourishes and confounds nearly every aspect of our lives. Indeed, the meaning of human ecology is embedded in those two words and their implicit relationships. We're here thanks to an ancient and strikingly creative resolution of the each-other problem. Sometime between 2 billion and 3.5 billion years ago, a large primitive bacterial cell engulfed a smaller type of bacteria as food, or maybe the smaller cell had invaded the larger one as a parasite. Maybe that predation or parasitism had been going on for millions of years, but on this occasion, the smaller cell stayed alive inside the larger one, probably because it happened to perform a useful function, maybe metabolizing a waste product or generating oxygen. And it reproduced in synchrony with its host. And over time, the two co-evolved, became increasingly mutually dependent, and eventually couldn't live apart. They had shed their each-other distinction, gaining increased success by living together as one organism, though both retained their own DNA and continued to reproduce in synchrony. It probably took a series of such colonizations by different bacteria to make the complex nucleated cells that form every plant, animal, and fungus that's ever lived, including us. And the ancient colonizers are still with us as organelles inside all our cells, mitochondria that provide chemical power for all cell processes, chloroplasts that use sunlight to make the carbohydrates that power nearly all the food webs in the biosphere and also provide the oxygen we breathe, centrioles that form the filamentous skeletons of cells, and the spindle that transports chromosomes during cell divisions, thereby driving sexual recombination and genome diversity, and cilia and flagellae that cells use for rapid movement. All of these come from such colonizations and such cooperation. So clearly our earliest single-celled common ancestors, dumb as they were, quickly learned the advantages that come with taking care of both each and other. And that ancient cooperation underlies everything we see today. And now, billions of years later, we're still constantly engaged in each other decisions at every level. At the subcellular level, our genes normally function as part of an organized collaborative, a self-regulating genome, in our case, a web of perhaps 30,000 genes and a large but still unknown number of control regions. When a mutation destroys a gene's control region, allowing that cell line to grow at the expense of other cells in the body as a whole, as happened in me, we call this condition cancer. Each other mistakes at this level cause about 200 different kinds of cancer in humans. At a slightly larger scale, the beta cells and T cells of our immune system that ceaselessly patrol our tissues to destroy any virus, microbe, or chemical recognized as other, sometimes make mistakes too, attacking our own tissues in one of the 140 or so autoimmune diseases that have been described. The 3 trillion cells of our nervous system are also busy with each other decisions. Bathed at every moment with information from every sense, our neurons compete and negotiate about what to notice and store, what associations to attach, what feelings or memories to inhibit, and what to retrieve. Each helps to form detailed tableaus of information, such that a sound, a breath of wind, a scent, or the taste of a petit madeleine dunked in tea might suddenly recreate a whole scene, or not. If certain neuronal pathways grow dominant, obsession, compulsion, tics, or other deviations from harmonious nervous integration may ensue. Mirror neurons blur the distinction between each another in a remarkable way. Mirror neurons are nerves that fire when we observe other people performing a movement. By mimicking the nervous activity ongoing in others, they help us imitate, learn, and perfect the observed actions. And mirror neurons probably also stimulate the empathy we feel when we see people or animals in distress, such that their emotional state is actually physically recreated in us. The each other story gets even more interesting when organisms interact. And I might say commencement seemed like a good time to talk about this because of the similarity between the word commencement and commensal. The com is shared, it means together, but commencement actually comes from the root for initiation of priests especially, and commensal from table, for eating together at the same table. Commencements have so far only included our species, but commensalism typically involves 2 or more species. For example, barnacles that grow on whales, or remoras that hitchhike on sharks and eat some of the particles dropped during their meals, or clownfish like Nemo, who gain protection by living amongst the venomous tentacles of sea anemones. In commensal relationships, one organism benefits and the other is neither significantly benefited nor harmed. You might think of it as tolerance or even ecological welfare. Over time, many relationships that likely began as commensal or possibly predatory or parasitic have evolved to become more mutually beneficial. And our growing awareness of that trend sheds refreshing light on the each other relationship, which Western society has usually interpreted as competitive. Thus, competition between individuals, each and other, was Darwin's mechanism for evolution through natural selection, the survival of the fittest. And even though Darwin included many fascinating examples of coevolution and cooperation or collaboration, the competitive paradigm remained essentially unchallenged until some scientists in the 1950s and 60s began to wonder whether evolution might also work at the group level by favoring groups of individuals who cooperated over other less cooperative groups. The idea went nowhere until the 1970s and 80s, when studies of social insects, especially ants and bees, and some other organisms, as well as theoretical advances in game theory, led the way to showing how important cooperation is throughout the animal, fungal, plant, and microbial kingdoms, and also began to reveal some of its genetic, physiologic, and behavioral bases. We learned that cooperation, whether unconsciously mediated by chemical communication or consciously nurtured, underlies countless interactions that enable life as we know it to exist. Mutualism between nitrogen-fixing bacteria and legumes powers many of our food crops: peas, beans, peanuts, lentils, carob, and many others, as well as plants crucial to ecosystem function, enhancing soil fertility at the same time. We've been amazed to learn that 90% of all plants obtain their mineral nutrients from symbiotic relationships with soil fungi, and 90% also depend on the insects and mammals that have co-evolved to pollinate them. As another example, without nourishment from their endosymbiotic algae, tropical coral reefs, the richest and most biodiverse ecosystems on this planet, would not exist. So cooperation is key, and life slowly works toward achieving it. Given time, even pathogens evolve to be less harmful to their hosts, working their way toward more commensal or even mutually beneficial relationships with the hosts. The communities of bacteria, fungi, and ciliates, protozoans that digest cellulose in the rumens or intestines of cows, horses, and every other animal that eats shoots and leaves likely made that journey, as did the bacteria that produce vitamin K in our intestines. When individuals interact, attention to both each and other can also accelerate the evolution of intelligence and consciousness. Any animal smart enough to recognize the individuals it frequently encounters and to remember how they behave has the potential to evolve mutualistic behavior based on reciprocal altruism, even when no genetic relationship exists. Encouragement of mutually beneficial and perhaps physically enjoyable acts enabled cleaning symbioses to evolve between different species of fish, or between birds and turtles, or birds and iguanas, and land tortoises and crocodiles, and some mammals too. Cleaners glean parasites from their clients, and clients presumably recognize and shun cleaners who cheat by eating scales or tearing skin or drinking blood. Reciprocal altruism occurs in mammals too, especially in bats, cetaceans, and primates. Who would have predicted that male vampire bats would be exemplars of kindness, regurgitating blood to feed nearby genetically unrelated males, with every good expectation that another day those males will feed them when they're hungry? Whales, dolphins, and primates not only demonstrate such direct reciprocity, but also indirect reciprocity. In which indirect reciprocity is when a kindness or a helpful act is repaid by others who did not receive the benefits of the first act. Frequent repetition of such behaviors strengthens the webs of reciprocity that bind these societies together, to the point that pilot whales, white-sided dolphins, sperm whales, and others routinely put themselves in harm's way to assist schoolmates in difficulty, including genetically unrelated individuals. And reciprocity is so strong in these species that they often extend help across species lines, including to humans in distress. Of course, the continuing dichotomy between each and other also ensures that the mental development supporting reciprocity has a darker side, stimulating increasingly sophisticated ways to favor self over others. We and our primate relatives are astonishingly good at cheating and concealing our deceptions even from ourselves. And we're also skilled at detecting and remembering cheating in others. You might even say too skilled, as we nurse grudges, prejudices, slights, and offenses so long that we encumber many generations in antipathies and even blood feuds. So for us, as for all mammals, genetic relatedness and reciprocity are the two factors that have always been central to social organization, both fostering each's and others of varying scale. Nuclear family, extended family, matriarchy, patriarchy, and tribe for kinship, gender, cohort, school, community, race, religion, class, caste, and dozens of others for reciprocity. And both organize our personal behavior and that of our societies in powerful ways, involving us in numerous webs of mutual obligation and expectation, and binding us together in some cases while separating us in others. But a third factor offers nearly unlimited power to create and extend meaningful relationships between people of all kinds. In 1968, beautiful color photos of Earth taken from space united people everywhere by showing our shared home in its entirety for the first time. Those photos and Rachel Carson's writings gave birth to the environmental movement, and we've spent the following 4 decades studying our planet in ever greater detail. We still don't know how many species live on Earth. Estimates range from 5 million to 100 million. But since only 2 million have been described scientifically so far, it's no surprise that new discoveries abound everywhere we look closely. New species, genera, families, and even sometimes higher orders of life. Things so unusual that even experts who've spent their whole lives studying don't know what it is. We find complex communities of organisms living their entire lives hundreds of feet up in the canopy of redwood trees, or thousands of feet below the sea, where metallic sulfurous brines spurt from Earth's mantle into the ocean. We find organisms so bizarre that they might have sprung from pages written by Frank Herbert or Ursula Le Guin. Luminescent vampire squids, sea squirts that trap fish, more than 600 plants that attract and trap prey, worms that have no mouth, anus, or digestive system at all, but are nourished by tissues packed with endosymbiotic bacteria that gain energy by oxidizing hydrogen sulfide to crystals of elemental sulfur and nourishing the worms at the same time. I might say about this time, I began to think maybe I should title this speech Worms, Germs, and Sperms, but I refrained. Despite this enormous diversity, we've discovered the remarkable genetic kinship we share, not just with chimpanzees, our closest relatives, with whom we share some 98% of our genes, but with all of this remarkable life. And it is startling. Half of the 548 metabolic enzymes found in the bacterium E. coli are present in all living organisms, including us. And the genes that regulate patterns of body development and segmentation are identical in fruit flies, mice, and people, and probably descended unchanged from our common ancestors in Precambrian seas 590 million years ago or more. And what's more, our relatives are not just closely related, they have a lot to teach us. Just by looking and listening, we've learned from bats how to echolocate, from barnacles and mussels how to make better glues for surgery, dentistry, and industry, from cockleburs how to make Velcro, from desert beetles how to collect water, from fog more efficiently, from sharks how to make swimsuits that win Olympic medals, from humpback whale flippers how to build more efficient blades for wind turbines, and that's just the short list. And I can attest to the benefits of biodiversity, as the 2 immunosuppressant medicines keeping me in good health both come from soil organisms. One from the bacterium Streptomyces tsukubensis, isolated by Japanese scientists from soil in their country. The other from the bacterium Streptomyces hygroscopicus, found in soil on one of the most isolated islands in the world, Rapa Nui, Easter Island. And nature's learning a bit from us, too. YouTube is replete with dogs and cats that skateboard, and dogs that surf, cats that take care of crows, chimps and gorillas that sign, parrots that talk, elephants that paint, a hippo who tries to save an impala from a crocodile, and dolphins who blow and play with bubble rings. What might have been the role of such innovations in our own history? And where might these novelties lead, given enough space, time, and relaxation from the everyday demands of survival? We don't know. But in general, all species deserve the time and the space to achieve their own biological potential, just as we have. As we begin to understand how some of our fellow species tick, and not just physiologically and ecologically, but also how they experience the world sensorily, emotionally, and to some extent intellectually, we find still more commonality. We find that feelings such as excitement, anticipation, fear, pain, joy, guilt, and something that looks a lot like love appear to be more widespread in the animal kingdom than we previously wished to admit. We don't yet know how many of our fellow species have enough brain power and leisure to think in abstract terms about the world and their place in it. though we're pretty sure that some do. But we certainly do it more frequently and deeply than any of our fellow travelers, and with surprising results, too. Coming from a naive past that was largely ethnocentric, anthropocentric, and terracentric, we've invented ever more sophisticated instruments for looking outward, and it has been humbling. Go count all the sand grains on all the beaches in our world. It's about 7.5 quintillion. That's 17 zeros, 10 to the 17th. And when you get through, the number of stars in the known universe will still be 100 times larger. Think of it, 100 stars for every grain of sand on Earth. And who knows how many planets circle them, and how many possibilities there are for life of some kind to have evolved. One can only marvel at the scope and grandeur of this celestial play, and the likely insignificance of our role. And still, it's the only role we get. So even if we are merely travelers drifting in time on a droplet from the most recent cosmic sneeze, and even if we never contact any of the other intelligent life forms that must exist somewhere out there, we still want to play our role well and get a good review for our performance. And that will require a clearer understanding of our part, a lot more rehearsal time, and far-seeing direction. Even if you never felt particularly close to an E. coli, a fruit fly, or a mouse, new insights show how closely related you are, and I am, to every other human alive. If the single origin theory is correct, and genetic evidence strongly supports it, all human mitochondria descend from a single female, a mitochondrial Eve who lived about 160,000 years ago. And all men inherited our Y chromosomes from a Y chromosomal Adam who lived about 60,000 years ago. And all direct human ancestors lived in Africa until approximately 70,000 years ago, when about 150 people migrated from what is now Ethiopia across the mouth of the Red Sea and into the Arabian Peninsula, from where they gradually spread throughout the rest of the world. Think of it. All of us descend from a restless group that was about the size of the group that processed today, including the bagpipers. And all the human variety we see today has evolved in fewer than 3,000 generations, and most of it, certainly cultural differences, much more recently than that. Those 3,000 generations haven't always been a smooth trip. There have been volcanoes and ice ages and droughts and lions and crocodiles and 1,000 other extrinsic challenges. But altogether, we've had the chance to grow up in a garden that is beautiful, prolific, and for the most part, hospitable. Our journey has brought out the worst and the best in us. Our burgeoning human population, now approaching 7 billion, and our worldwide activities and effects are now so pervasive that the fate of nearly all species, domestic or wild, depends on us. In essence, we've brought nearly every species from a state of wildness to commensalism, feeding at our table through our tolerance for them or whatever habitats we leave for them. And lately, we've begun to feel the resulting ecological pushback and to realize its seriousness and extent. Land use changes and deforestation at a planetary scale, destruction of natural habitats, rivers that don't carry water anymore, climate change, ocean acidification, increasing sea level, massive extinction of species, reduction of ecosystem services, and the deterioration of human health as pathogens and parasites co-adapted with their wild hosts suddenly spread to a brand new host, us, causing zoonotic diseases such as AIDS, West Nile virus, dengue fever, Ebola and hemorrhagic fevers, and many more. And what's more, we've become the source of our own mortality and morbidity, either by killing each other directly through fighting and wars, or indirectly by failing to curb mortality attributable to poverty and ignorance. For example, infant and maternal mortality, waterborne illness, malaria. Paraphrasing the talking heads, you may ask yourself, well, how did we get here? How could we leave such a trail of carnage and destruction in our wake? It was easy. We only did it to others. And yet, as advances allowed some of us to devote more time to study and play and experimentation, we've developed a most astonishing range of skills and achievements, pushing the envelope of what it means to be human. We've learned to fly, visit the moon and nearby planets, map the universe and see traces of its beginning, share information and ideas instantly around the world, see atoms and smash them too, and move them individually, calculate massive problems at blinding speed and help the blind to see, map genomes and repair and transplant genes and organs, and even create primitive life itself. And this too is the short list. And now it's time to put skills like these to use in the largest and most far-reaching human project ever intentionally undertaken, repairing Earth. It's time to put the garden back together again. It won't be mitochondrial Eve's or Y-chromosomal Adam's garden, for it will miss the giant ground sloths, flightless moas, dodos, stellar sea cows, passenger pigeons, Yangtze dolphins, and more whose extinction at our hands can't be reversed. But the sooner that we start, the more complete the garden will be. The project will require multi-generational dedication, patience, and a sense of collaboration with all our human and non-human partners, for they'll also have lots of work to do. Among other things, we will reduce the human population down to perhaps 3 billion people over the coming 5 to 10 generations by benign and voluntary means, through education, empowerment of women, and an appropriate system of incentives, disincentives, and alternatives to personal reproduction. And that number is about 500 million less than existed in 1968 when we first saw Earth from space and when Paul Ehrlich published The Population Bomb. We'll reduce our individual and societal impacts on the environment by using resources equitably and sustainably and not permitting other uses. We'll replace climate and habitat destructive methods of power generation with renewable energy from the sun, wind, waves, geothermal, and other sustainable sources. And we will retreat from areas that are ecologically and economically marginal, thereby releasing large areas to nature. Areas of land and sea restored to wilderness will repay our debt to the natural communities so fundamental to our own evolution and will guarantee a robust future for the ecosystem services on which we all depend. Of course, in the near term, we must also succeed with reforms of healthcare, education, economic oversight, international debt, arms control, environmental regulation. But the failure to achieve the longer-term goals will overwhelm those gains with unthinkable consequences. On the other hand, if we and the generations to come focus steadfastly on rebuilding the garden, we will eliminate poverty, grow healthy people and communities, and eliminate war and all the waste it entails, as there will be much more to share and much less to fight about. In the end, the key to our individual and collective success is sharing, whether it be space for nature, individual opportunity, information, energy, water, or stem cells. And the key to sharing is cultivating the sense of relationship and common purpose. There's overwhelming evidence of the interdependency and close relationships between all people and all life on Earth. Honoring those relationships is the only path to a beneficial future. Long ago, in Vedic times, Indra was the ruler of the gods. From his court in the clouds above Mount Meru, he defended gods and men from evil, commanded thunder and storms, and brought water to the earth. Atop his court, a marvelous net stretched to infinity in all directions. At each intersection of the net lay a brilliant jewel, and the infinity of jewels sparkled like stars in the heavens, each jewel catching and reflecting the reflections of all the others, and the reflections of those reflections, merging each, other, and everywhere. Indra's net surely extends to Earth, where all living things are its jewels, endlessly reflecting and echoing the shared history of all life and all people, not only those alive today, but all those who have gone before, because they still live in us, in our genes, cells, emotions, memories, and cultures. In that spirit, let congratulations shine on the class of 2009 from your many boosters here in the tent and those cheering from afar, but also from countless long-dead ancestors of all kinds. None could have known that their efforts would ultimately produce you. Most weren't put together in ways that enable such a concept or any concept. But you and we all are nonetheless in their debt. For though you worked hard for a quarter century to get to this milestone, they've been working for you for several billion years. And there's no better way to honor their contributions and our shared past than by creating a better common future. And your work toward that goal already sparkles through IndraSnet. Thank you very much.
What a wonderful and inspiring speech, Steve. I hope we have a chance to see that in hard copy because there's so much depth in it that we would like to consider it more fully. The speech itself demonstrates the scientific grounding of Steve and all that he brought to the college during his years as founding faculty and faculty member and president. I just want to mention one thing of many that he brought to the college during his 14 years of presidency. You look at these flags around you. These are not naval flags with signals. These are flags representing the nations of the earth. And Steve, by his foresight, ability to convince and connect, and also by the generosity of the Davis family who started the international program at this college, the United World College Scholars Program, is another giant step in bringing the world to the college, which you did in science first, and then in many other ways, including this. And now we have a surprise, something not in the program. It's hard to keep a surprise in College of the Atlantic. Communications are so good that they often leak out. But maybe this is a surprise. It is now my great pleasure to confer upon you an honorary Master of Philosophy degree in human ecology, Steve Katona, with all of our heartfelt thanks.